As of now, the James Webb Space Telescope recently sent an exceptional message, leaving NASA researchers totally flabbergasted. As the main optical telescope in space, it has been looking at different areas of our vast universe for a considerable time, uncovering various quirks. However, the most recent image it sent has shaken the worlds of science and cosmology. What enthralling picture has the James Webb Telescope captured? Could it have the possibility of capturing an extraterrestrial spacecraft on the farthest edges of space? Join us as we dive into these mysterious new images the James Webb has uncovered, images that were previously unseen. If you want to stay fully informed of universe-wide updates and its natural elements, make sure to subscribe to our channel, give this video a thumbs up, and enable notifications. NASA's $10 billion James Webb Space Telescope was launched from a European spaceport. After reaching the French Guiana spaceport, its intended destination, this infrared observatory provided breathtaking views of the universe to scientists and astronomers. As the most advanced and largest space telescope to date, researchers wanted to look into the first scientific images captured by the telescope. What they found almost left them stunned. When James Webb aimed its instruments at the famous pillars of creation, it captured the iconic dust clouds in unprecedented detail. These pillars, located inside the Serpens constellation, are around 7,000 light-years from Earth. The pillars of creation are part of the Eagle Nebula, vast clouds of gas and dust first imaged by the Hubble Space Telescope in 1995. Ever since, the dazzling glow at the tips of the pillars has been visible. The latest photo captured by the James Webb reveals the pillars of creation with even more intricate detail. Several stars are now visible that were not apparent in previous Hubble images, some of which formed millions of years ago. This marks a significant leap in scientific knowledge. Additionally, the James Webb Space Telescope has examined a region called Pandora's Cluster, CL, capturing a stunning image named after Greek mythology. Pandora's Cluster is a section of space predicted by Albert Einstein in 1952. These new images have amazed scientists, as they reveal previously unknown aspects of this region of space. It is important to note, however, that this region has an official name, SMACS 0723, which belongs to Pandora's Cluster. This cluster contains a mix of unique structures. What makes this image particularly fascinating is that, while it has been observed before, only the central part of this region had been examined by the Hubble Space Telescope. This suggests that there are still cosmic wonders yet to be uncovered. Until James Webb focused its advanced infrared technology on the area to analyze Pandora's cluster, astronomers had only a limited understanding of its composition. The research team used the telescope's powerful instruments, including the spectrometer for the near-infrared, NIR-SPEC, and the near-infrared camera, NIR-CAM. As a result of their in-depth observation program, they captured stunning ionotation images that were merged into a comprehensive view. This extensive image revealed approximately 5,000 infrared light sources within Pandora's cluster, which is approximately 3.5 billion light-years away. The image taken by the James Webb achieved an impressive balance of depth and scale, potentially changing our perception of the cosmos' evolution. A highlight of the image is a bright star in the foreground, with a distinctive diffraction pattern created by the James Webb Space Telescope. Also visible are bright sources of white light surrounded by dark areas, representing even more distant galaxies within Pandora's cluster. While human-made technology is crucial for exploring this cosmic cluster, astronomers have also relied on a natural phenomenon predicted by Albert Einstein in his theory of general relativity, published in 1915. The ongoing discoveries continue to captivate researchers and space experts. The James Webb Telescope has captured astonishing cosmic anomalies that even experts cannot fully explain. One such mystery is the bewildering concentric rings observed around a distant star, a phenomenon that is still not completely understood by space scientists. The image was shared on Twitter by a researcher, sparking a wave of comments and conversations within the online community. The picture showed a star named WR140, surrounded by wavy, ripple-like circles that gradually faded. What stood out was that the circles were not perfectly circular but had a somewhat square shape, quickly resulting in speculation about a possible extraterrestrial origin. However, some experts argued that it was simply nature behaving in a way that appeared exceptional from a single point of view. Sometimes natural phenomena can seem dynamic from certain angles but have straightforward explanations. Yet, questions persist. Why do they have that specific shape, and why do they appear so uniform? These questions have left experts such as Mark McFarland, a multidisciplinary researcher with the JWST science team, puzzled. He called the occurrence remarkable. In a Twitter post, he explained that the sharp blue pattern is an effect of optical diffraction from the bright star WR140 in the image. Nevertheless, he noted that the red wind is real, symbolizing a collection of shells that surround WR-140 in space. Although NASA is expected to provide an explanation soon, it is well known that young stars frequently release blue light while older stars shift to a redder hue as they burn their fuel and cool. Astronomers had no idea they would see red stars from the beginning of the universe, an unanticipated finding that the James Webb Telescope was designed to explore. Finding galaxies several times larger than expected, these red spots revealed in images captured by the James Webb Space Telescope seem far more massive than anticipated. According to Jan Lear, the most massive galaxy in their sample is estimated to be only a few times smaller than the Milky Way. This discovery is surprising because galaxies of the Milky Way size were found when the universe was only 3% of its current age. Lear also stated that before astronomers start adjusting cosmological theories to explain how such large galaxies formed so quickly after the Big Bang, they must first ensure that the mysterious red spots they are observing are not something else. Otherwise, other explanations would necessitate groundbreaking ideas, for instance, that stars in the early universe could have emitted light in unexpected ways due to a lack of heavy elements, which are not accounted for in our current models. The images that brought to light these enigmatic galaxies were taken by NIRCam as part of the early release science program. The team plans to return soon to these galaxies and the SMACS 0723 cluster to gather spectra of light coming from faraway sources. Spectra, analyzed by breaking down light into wavelengths, reveal the physical and chemical characteristics of the sources. Particularly, spectra also offer highly accurate distances to these objects. Lear emphasized that, just a few months after Webb's team released the first observations, researchers are already re-evaluating their theories about the early universe. Observing the early universe for the first time led to the discovery of something so astonishing that it challenges science as a whole, reversing our understanding of early cosmic evolution. Fundamentally advancing our understanding of the universe. As it peers deeper into space and further back in time than any telescope before it, the James Webb Space Telescope, JWST, is unlocking cosmic secrets that scientists could only dream of accessing until now. Among the telescope's most groundbreaking contributions is its ability to detect light that has traveled for over 13 billion years, nearly reaching the time of the Big Bang itself. Through its sophisticated infrared instruments, Webb can pierce through thick clouds of cosmic dust, unveiling young, forming galaxies and revealing the earliest stages of stellar evolution. One of the most astonishing aspects of JWST's findings is how they hint at a much faster and more chaotic early universe than previously theorized. Where astronomers expected to find small, primitive galaxies gradually merging to form larger structures, Webb instead revealed mature, massive galaxies already formed when the universe was just a few 100 million years old. This startling discovery suggests that star formation processes and galaxy assembly may have been far more efficient, or fundamentally different, than our current models predict. Furthermore, the James Webb Space Telescope's ultrasensitive spectrometers have allowed scientists to detect chemical signatures, including complex organic molecules, in distant exoplanet atmospheres. This has profound implications for the search for extraterrestrial life. By analyzing the light passing through these atmospheres, researchers can identify elements like carbon, oxygen, and methane, potential biosignatures, sparking excitement about the possibility of habitable worlds beyond our solar system. Beyond galaxies and exoplanets, JWST has also captured breathtaking images of phenomena such as gravitational lensing, where massive celestial bodies bend the fabric of spacetime and magnify distant objects behind them. This effect, predicted by Einstein's theory of general relativity, is not just a visual wonder. It is a crucial tool for mapping dark matter and understanding the invisible scaffolding of the universe. Each new image and set of data sent back by Webb continues to reshape humanity's view of the cosmos. Whether it's the stunningly intricate dust lanes of distant galaxies, the eerie glow of dying stars, or the surprising discovery of massive, mature galaxies at the dawn of time, the James Webb Space Telescope is pushing the boundaries of what we know, and what we thought was possible. As NASA and collaborating scientists continue to process and analyze the troves of information being collected, the coming years promise even more paradigm-shifting revelations. The James Webb Space Telescope isn't just a tool for observation, it is a time machine, a cosmic archaeologist, and a beacon illuminating the most profound mysteries of existence. Stay tuned, as we stand on the brink of discoveries that could forever change our understanding of the universe, and our place within it. The universe, one of its most remarkable achievements, is its ability to capture light from some of the earliest galaxies known to exist. Thanks to the James Webb Space Telescope, made with advanced infrared technology, new insights have been gained from observations into the growth and development of these ancient galaxies, deepening our understanding of the early universe. Recent images from Webb have revealed galaxies in various stages of development, showcasing intricate details of early universe mergers, where galaxies collide and interact. These mergers are key events in the life cycle of galaxies, influencing their structure and star formation rates. The telescope's detailed observations of these processes are helping scientists piece together a look back at the formation of galaxies, a glimpse into how galaxies like our own, the Milky Way, may have evolved over billions of years. In addition to its investigation of distant galaxies, Webb has also focused on nearby celestial bodies, like stars forming in parts of our own galaxy. Its ability to see through dense interstellar dust has allowed astronomers to study the birth and evolution of stars with unprecedented detail. For instance, Webb has provided new views of regions like the Orion Nebula, one of the closest and most active star-forming areas to Earth. These observations are helping scientists understand the complex processes involved in stellar birth and the formation of planetary systems. Another key area of research facilitated by Webb is the study of exoplanets. The telescope's infrared capabilities are ideal for analyzing the atmospheres of exoplanets, allowing scientists to identify and define their compositions. Work with Webb has already begun investigating the atmospheres of several exoplanets, providing crucial information on their temperature, atmospheric composition, and potential signs of habitability. This information is essential for identifying planets that could support life and for understanding the conditions that may influence distant worlds. The James Webb Space Telescope, with its exclusive capabilities, is unveiling details of the universe that were previously beyond our reach. Its powerful infrared technology allows it to see through vast cosmic dust clouds, capturing phenomena that would have been invisible to earlier telescopes like Hubble. This ability is particularly significant when observing regions of space where new stars are being born or where galaxies are in their early stages of formation. The insights gained from Webb's observations promise to alter our understanding of the universe, pushing the boundaries of what we know about cosmic evolution and the birth of celestial bodies. One of the most groundbreaking discoveries made by Webb is its capacity to capture images of galaxies that existed when the universe was still in its earliest stages, just a few 100 million years after the Big Bang. Frequently, these galaxies are much larger and more complex than scientists had expected, challenging preconceived notions about galaxy formation. Astronomers are now faced with the difficult task of adjusting their models to account for these unexpected findings. The immense size and complexity of some of these early galaxies suggest that the universe may have undergone rapid and dramatic changes much sooner than previously believed. Webb's deep space imaging capabilities have also drawn attention to unexpected phenomena, such as the concentric rings around the star WR-140. This intricate observation has sparked intense debate among astronomers, as the unusual form and behavior of the rings defy simple explanations. Some researchers speculate that these rings could be the result of an optical illusion caused by the telescope's patterns of diffraction, while others suggest they may represent a more fundamental cosmic mystery. Regardless of the explanation, the finding of these strange rings highlights the power of the James Webb Space Telescope to uncover unexpected characteristics of the universe. The telescope's observations extend beyond distant galaxies to our own Milky Way, especially focusing on the formation of stars. In regions such as the Orion Nebula, capturing images in the infrared spectrum, Webb has revealed never-before-seen details about how stars and planets come into existence. The ability to peer through the thick clouds of dust and gas that surround young stars has provided astronomers with valuable information about the processes that result in the formation of planetary systems. These discoveries offer crucial clues about the origins of our own solar system and how other planetary systems may develop. Moreover, the James Webb Space Telescope has made significant strides in the study of exoplanets. Its ability to analyze the atmospheres of these distant worlds is transforming our approach to searching for signs of life beyond Earth. The infrared technology of Webb allows it to detect the chemistry of exoplanet atmospheres, providing insights into their potential habitability. In particular, the telescope is centered on determining the presence of water vapor, carbon dioxide, and methane, key markers that could indicate the possibility of life-supporting conditions on these distant planets. One of the most promising aspects of Webb's mission is its potential to answer some of the most profound questions in science. As it captures more images and collects more data, the telescope will continue to challenge existing theories about the universe's beginnings, the nature of dark matter and dark energy, and the conditions that support life. The discoveries made by Webb in the coming years will likely lead to a deeper understanding of our place in the universe and could help guide future missions to explore the farthest reaches of space. In summary, the James Webb Space Telescope is proving to be an invaluable instrument in the effort to understand the universe. Its advanced infrared capabilities and powerful instruments have allowed astronomers to observe the distant past and peer into the heart of cosmic phenomena that were previously invisible. From capturing the formation of new stars and galaxies to locating bizarre cosmic anomalies, Webb's observations are reshaping our understanding of the universe and offering a glimpse into the mysteries that lie beyond our reach. As Webb continues its mission, each new set of observations deepens our comprehension of the cosmos. Scientists anticipate that upcoming studies will provide even sharper images of the universe's earliest epochs, helping to pinpoint when and how the first stars and galaxies emerged from the so-called cosmic dark ages. One particularly exciting frontier involves the search for first light, the earliest luminous objects to illuminate the universe after the Big Bang. By detecting the faint infrared glow of these ancient structures, Webb may offer definitive answers about how the first galaxies assembled and how their energetic processes shaped the subsequent evolution of the universe. In parallel, Webb's powerful instruments are being used to explore the mysterious composition of dark matter and dark energy, which together account for roughly 95% of the universe's total mass energy content. Although invisible, their gravitational effects can be inferred through Webb's detailed measurements of galaxy clusters and the bending of light, a phenomenon known as gravitational lensing. These observations could provide critical clues about the unseen forces that govern the structure and destiny of the cosmos. Another promising application of Webb's capabilities lies in the study of the life cycle of stars, from their turbulent births to their dramatic deaths. By examining stellar nurseries and supernova remnants with unparalleled clarity, Webb will enable astronomers to reconstruct the full narrative arc of stellar evolution, revealing how elements essential for life, like carbon and oxygen, are forged and dispersed into space. Additionally, Webb's ongoing survey of exoplanetary systems continues to captivate the scientific community and the public alike. Its ability to detect atmospheric components such as water vapor, methane, and carbon dioxide is bringing humanity closer to answering the age-old question, are we alone in the universe? By identifying potentially habitable planets and analyzing their atmospheres for biosignatures, Webb is laying the groundwork for future explorations, missions that might one day directly detect life beyond Earth. Beyond its immediate scientific objectives, the James Webb Space Telescope serves as a symbol of international cooperation and technological achievement. Developed through a collaboration between NASA, ESA, the European Space Agency, and CSA, the Canadian Space Agency, Webb represents a unified global effort to push the boundaries of human knowledge and curiosity. As more data pours in from Webb's instruments, each discovery opens new questions, ignites fresh debates, and challenges established paradigms. Whether it is redefining the timeline of galaxy formation, uncovering the secrets of dark matter, or spotting signs of life on distant worlds, Webb's influence on astronomy, astrophysics, and planetary science will be profound and enduring. Ultimately, the James Webb Space Telescope is not just a tool for observing the universe, it is a time machine, a chemistry lab, a cartographer of the unseen. It invites us to look deeper, think broader, and dream bigger about our origins and our place in the cosmos. The universe, in all its vastness and mystery, is slowly revealing its secrets, and Webb stands at the forefront of this grand cosmic exploration,